I want to start by saying something that most of my colleagues would refuse to put in writing. We were wronged. Not just a little wrong. Not the kind of wrong where you go back and tweak your calculations and feel slightly embarrassed at the next academic conference. I mean deeply, fundamentally, cosmically wrong in a way that required us to sit down, shut up, and completely rearrange everything we thought we understood about intelligence. My name is Theshaven Rel. I have 3 doctorates from the Vilthari Institute, one in xenomathematics, one in ancient civilizational physics, and one in something called resonant architecture theory, which is a very fancy way of saying I spent 30 years of my life studying a device that nobody could figure out how to turn on. I was there that day. I was standing exactly 4 meters and 20 centimeters from a 16-year-old human girl when she walked up to the Surath engine, the most complicated, most debated, most studied object in the known galaxy, and figured it out in approximately 11 minutes and 40 seconds. I counted. I had nothing else to do. We had all failed so many times that counting felt like the only thing left. Let me tell you how we got there, because the story of the Surath engine isn't just about that one afternoon, that one girl, that one impossible moment. It's about 5,000 years of the smartest minds in the galaxy running full speed into a wall and not understanding why the wall wouldn't move. It's about what happens when intelligence gets so comfortable with itself that it stops being able to see clearly. It's about us mostly and what we missed. Chapter 2, Discovery, 4,891 years before the girl. The planet is called Vithrak Prime now. It wasn't always. When the Scalith expedition first landed there, back in what the Galactic Consortium calendar marks as year 0 of the 3rd expansion, it was just a dead rock orbiting a dim star in the outer spiral, nobody's first choice for anything. Commander Scalith Morrow, the expedition leader, described it in her log as profoundly unremarkable. She wrote that the soil was gray, the air was barely breathable, the mineral composition was ordinary, and the whole planet smelled faintly of rust. She was mostly right, except for the one thing sitting in the middle of a plateau, roughly 400 kilometers from where they landed. The expedition geologist found it on the 4th day. He almost tripped over it. Actually, the ground around the plateau was uneven and he was watching his feet. He looked up and there it was, this enormous structure, perfectly circular, maybe 60 meters in diameter and about 12 meters tall at its center point, sitting on the plateau like it had been placed there specifically to be found. The log entry from that afternoon is in the archive. I've read it probably 400 times over the course of my career. It doesn't look like geology. The angles are too deliberate. There are markings on the surface, not erosion patterns, not natural crystallization. Markings. Someone put this here, I don't know who, I don't know when, but I know someone built this. They spent 6 weeks on the initial survey. They cataloged every marking, mapped every surface irregularity, took thousands of material samples. The composition was unlike anything in the known mineral database. A lattice of elements that shouldn't naturally occur together, bound in a crystalline structure that defied standard bonding theory at the time. When they left, they took every measurement they could carry and left a beacon on the plateau. That beacon is still there. We've replaced it 47 times over the centuries, but there's always been a beacon on that plateau because the Surath engine, named eventually for the expedition's lead materials scientist, Dr. Corval Surath, who spent the next 60 years of his life studying it, has never stopped being worth watching. Chapter 3, What We Understood Eventually. Over the next 500 years, the scientific consensus on the Surath engine went through what I can only describe as a long and painful adolescence. The first generation of researchers thought it was a tomb. The markings looked ceremonial, rhythmic, geometric, layered. They spent about a century excavating around the base looking for burial chambers. They found nothing. The engine goes down about 40 meters into the plateau, but there's nothing inside except more of that impossible crystalline lattice, arranged in increasingly complex geometric patterns the deeper you go. The second generation thought it was a map. Some of the marking sequences corresponded roughly to star configurations visible from the plateau on certain evenings. This theory lasted about 200 years and produced 17 major academic papers, 6 of which directly contradicted each other. The third generation, this is where things started getting genuinely interesting, realized that the markings weren't decorative at all. They were functional. The engine was a machine. It was built to do something. The patterns weren't random and they weren't just symbolic. They were instructions. This was around year 800 of the consortium calendar, give or take. The problem was, we couldn't figure out what the instructions said. Not for lack of trying. By year 1000 we had 14 permanent research stations on Vithrock Prime. By year 1500 we had a full academic city, 20,000 researchers, support staff, administrators, all living on that gray planet in that rust-smelling air, all dedicated to figuring out what the engine was supposed to do. By year 2000, the leading theory was that the engine was a power amplification device, something that could channel and focus energy from a star, potentially enough to power a civilization for millions of years. If that was true, figuring it out would be one of the most significant technological leaps in galactic history. That theory was partially correct, but only partially. Chapter 4, The First Contact with Humanity. I should explain where humans fit into all of this, because they didn't just appear suddenly. They'd been in the picture for a while before the day I'm describing. First contact with the human species happened about 400 years ago, in year 4490, one of the consortium calendar. Standard first contact protocol, cautious approach, communication attempts, language bridge construction, the whole careful dance that the consortium had refined over centuries of meeting new species. Humans were unusual from the start, not dangerously unusual, not frighteningly unusual, just different in ways that took a while to categorize. The initial assessment classified them as a Class 4 intelligent species, capable of complex reasoning, symbol use, social coordination, and technological development, but below the cognitive threshold for abstract multidimensional mathematics, which was what most of our best work required. The consortium used a standardized battery of cognitive assessments that had been developed over 2,000 years and validated across 63 species. Humans scored well on some parts and poorly on others. They were excellent at pattern recognition, excellent at emotional reasoning, excellent at what the assessment called contextual lateral synthesis, which is a technical term for the ability to pull two things together that don't seem related and find the connection nobody else saw. They were poor at sustained multi-axis mathematical modeling, poor at high-dimensional geometric visualization, poor at the kind of recursive logic problems that formed the basis of most consortium advanced science. The conclusion was that humans were a young species with significant potential, but not yet ready for full integration into advanced research programs. They were admitted to the consortium as associate members, welcome at diplomatic functions, permitted to trade, allowed limited access to shared technology, but not invited to the serious table. Most of my colleagues thought this was reasonable, generous even. I'm not sure what I thought at the time. I was junior faculty then, and I didn't have opinions that anyone cared about. I just did my work. But I remember meeting my first human at an academic conference in year 4510. Her name was Dr. Patricia Aucaffer. She was one of only 3 humans in attendance, and she'd been invited essentially as a diplomatic courtesy. She was a physician, not a physicist. She had no business being at a xenomathematics conference. She spent the entire 3-day conference sitting quietly in the back of every session, watching, listening. Never asked a question, never tried to insert herself, just watched. On the last day, during a presentation about the Surath engine's marking structure, she raised her hand. The presenter, a very distinguished Velthari researcher named Professor Selvin, who had 40 years of engine study behind him, paused with visible reluctance and gave her the floor. She said, very quietly, "The pattern in the third quadrant of the eastern face, has anyone considered that it might be a sequence rather than a diagram? Like it's telling you to do something in order, not just showing you what something looks like." There was a pause. Selvin said, politely but firmly, that the pattern had been analyzed exhaustively and was most likely a topographical representation of the star field visible from the plateau. Dr. Aucaffer nodded and sat back down. She was right, of course. We figured that out about 140 years later. But nobody put it together at the time. And nobody remembered that she'd said it until I went back through the conference transcripts decades after the main event. Chapter 5. What 5,000 Years of Failure Looks Like. I want to give you a real sense of what it means to study something for 5,000 years and not solve it. It's not dramatic. That's the first thing to understand. Failure at that scale doesn't feel like constant agony. It becomes a kind of background condition. You live inside the failure. You build your career around it. You develop elaborate systems for understanding why you haven't solved it yet and what you're going to try next, and those systems become their own kind of comfort. By the time I joined the Vithrock Prime research team in year 4600, about 300 years after human first contact, there were 28 active theories about the engine's primary function, all of them internally consistent, all of them supported by evidence, and none of them compatible with any of the others. The atmosphere on the station had this particular quality that I've tried to describe to people who weren't there. It was like being in a very old, very prestigious library where everyone is convinced there's a critical book they haven't found yet. Serious, purposeful. But underneath all that seriousness, very quietly, very deeply exhausted. You could see it in the way the senior researchers walked. There was a particular way that the old guard moved through the corridors of Research Station Theta, our main facility, about 2 kilometers from the plateau, that I still dream about sometimes. Slow, careful, like every step had weight. They had each given decades to this problem. Some of them had given their entire careers, and the engine just sat on that plateau and didn't tell them anything. The marking sequences had been fully catalogued for 3,000 years. We knew every line, every depth variation, every surface texture irregularity. We had more data on the Surath engine than on almost any other object in the known galaxy. We had run every computational model we could devise. We had applied every theoretical framework we had. Nothing. The engine was warm, always, about 4 degrees above the ambient temperature of the plateau, every measurement, every season, every year, for as long as anyone had been measuring. That suggested an internal energy source. Something was happening inside it. Something was running. But we couldn't find the interface. We couldn't find the access point. We couldn't figure out how to interact with it in any way that produced a response. Chapter 6. The Youth Exchange Proposal. In year 4740, a human diplomat named Ambassador Chen Wei proposed what he called a cultural scientific exchange initiative. The idea was simple on the surface. Open some of the consortium's advanced research projects to young human researchers, not just credentialed scientists, but also exceptionally talented students, as a way to accelerate human integration into the galactic scientific community. Most of the consortium's senior council dismissed it immediately. The polite version of the argument was that mixing inexperienced students into serious long-term research projects would create inefficiencies and potentially contaminate years of carefully controlled data. The less polite version, which I heard in private conversations, was that nobody believed humans were advanced enough to contribute anything meaningful, and having them wandering through high-security research sites was a liability. Ambassador Chen was not deterred. He came back with a revised proposal every year for 16 years. Finally, in year 4756, the Council approved a limited pilot program. 3 research sites would be open to a small cohort of human participants, a mix of early career researchers and what the proposal called gifted young scholars, meaning students in the top percentile of human academic performance. Vithrock Prime was not on the original approved list. Professor Yasindra Cole, who was then the station director for Research Station Theta, specifically requested that it be added. When I asked her years later why she made that request, given how sensitive and restricted engine research was, she thought about it for a long time before answering. She said, "We had tried everything we could think of, everything a very smart, very experienced, very trained mind could devise. I wanted to see what a completely untrained mind would do with it. I was curious." She paused. Then she added, "Also, frankly, I was desperate." Chapter 7. The Cohort. The first cohort arrived at Research Station Theta in what I still think of as the most quietly significant moment in galactic history, though none of us knew that at the time. There were 11 of them, 7 early career human researchers, aged between 25 and 40 in human years. 4 students, gifted young scholars, as the program called them, between 15 and 18. I was assigned to be one of the welcoming faculty. Station Director Cole made it clear that we were to be courteous, inclusive, and professional. She used the phrase, genuinely open-minded, approximately 4 times in the briefing, which told me she'd had conversations with people who were planning to be none of those things. I met the cohort at the shuttle bay. They were smaller than I expected, most of them. Humans are not a large species. Even the adults seemed compact and somehow vulnerable in the station environment. They wore the standard visitor biosuits we issued to all species that couldn't breathe the plateau air comfortably, which made them look even smaller, round helmets, padded suits, moving through the gray corridors with careful, deliberate steps. The 4 students clustered together, the way young people do anywhere. 3 of them kept looking around at everything with wide eyes, clearly overwhelmed. One of them was looking at the floor. Her name was Myra Osei. I noticed her for a specific reason that had nothing to do with anything significant. She was carrying a notebook. An actual physical notebook, spiral-bound, with a pen clipped to the cover. Every other member of the cohort had standard digital recording equipment. She had a paper notebook. Later, I asked her about it. She said her grandmother had given it to her before she left and told her to write things down when she wanted to understand them. She said she'd always thought better on paper. She was 16 years old. She was from a place called Accra in West Africa on Earth. She had, according to her application file, the highest score ever recorded on the consortium's pattern recognition sub-assessment, not just for humans, but across all 64 species in the database. The assessment committee had flagged this as a probable scoring error. It was not a scoring error. Chapter 8, First Week, the engine observed. The program's structure was straightforward. The human cohort would spend 4 weeks at the station, 2 weeks in orientation and supervised observation, 2 weeks in assigned research shadow roles. They were not expected to contribute original research. The whole point was exposure and education. During the first week, the cohort was taken to see the engine. This was standard practice for all visitors. Honestly, the engine was the reason for the station's existence, and anyone who came to Vithrock Prime went to the plateau and looked at it. It was a formality, a tourist stop, a moment for photographs and a brief lecture about our current research approaches. I led the tour that day. I'd given the same tour probably 200 times over my career. I had the lecture memorized. I knew exactly where to stand, exactly how to angle the description so it sounded both impressive and appropriately humble about our lack of progress. It was a clear day on the plateau. The sky on Vithrock Prime is a dark, flat gray, like a ceiling lowered just a little too far, and the engine sits in the middle of the plateau and seems to absorb the sky rather than reflect it. Up close, it's not as obviously artificial as you might expect. The surface markings are subtle, almost shy, and you have to move around it slowly and look carefully before you start seeing the density of what's there. Most visitors react to the engine with awe. The sheer age of it, the alien intelligence behind its construction, the scale of the mystery, it tends to produce a particular reverent silence. The cohort did this, the adults, the 3 wide-eyed students. They stood at the observation boundary. We kept visitors about 15 meters back from the surface, and they looked at it and were quiet and impressed. Myra didn't stop at the boundary. She didn't even hesitate at it, she just kept walking. I called after her. She stopped, turned around, looked at the boundary markers, then looked at me with an expression of genuine confusion. "Sorry," she said, "am I not supposed to go closer?" I explained that the observation boundary was a strict research protocol. The area within 15 meters was a controlled zone where only credentialed researchers were permitted, to avoid any contamination of surface conditions. She nodded, she came back to the boundary, she stood there. And then she started writing in her notebook. For the entire rest of the tour, while I gave the lecture, while the others asked questions, while we moved around the circumference, she stood at the boundary and wrote, not looking at her notebook much, looking at the engine and writing. I noticed this, but I didn't say anything about it. It was a notebook. It was a student being a student. It meant nothing. Chapter 9, First Week, the question. On the 3rd day of the first week, during a general Q&A session with the full research faculty, Myra raised her hand. We were in lecture room 4 at Station Theta. About 40 researchers present, including several very senior people who'd been studying the engine for longer than human first contact had been a thing. The session was nominally open to questions from the cohort, but in practice, the early career human researchers were asking careful, respectful questions about methodology, and the students were mostly quiet. Myra's hand went up. I was at the back of the room. I couldn't see her face, just the back of her head and the hand going up. Professor Selvin, very old by this point, still very distinguished, still the most senior engine researcher on the station, acknowledged her. She said, "I've been looking at the marking sequences on the eastern face, specifically the third and fourth quadrant clusters. I have a question about the directionality analysis." Selvin's expression shifted slightly. Not rudely, he was too professional for that, but there was a micro-adjustment, a recalibration of his attention, because this was not the kind of question he expected from a student. He said, "What aspect of the directionality analysis?" She said, "Well, all the analyses I've read assume the markings are meant to be read from the exterior of the engine toward the center. Like the audience for the markings is standing outside, looking in. But has anyone modeled what the markings look like if you assume the audience is inside, looking out? Like, what if these aren't instructions for someone standing here? What if they're instructions for the engine itself?" There was a pause. A long one. Selvin said, "That's an interesting framing. The interior structure has been extensively documented, and the interior marking sequences are." "I know," she said. "I read the interior surveys, but the interior surveys were analyzed as a separate system from the exterior markings. I'm asking whether anyone has tried to model them as two parts of the same communication. Like, the exterior tells you what to do, and the interior is the response. Or the interior tells the machine what to do, and the exterior is confirming it." Another pause. Selvin said, carefully, "The interior and exterior marking systems have different compositional densities and were hypothesized to be generated at different periods of the engine's construction, which suggested they were functionally independent systems." Myra said, "Right, but different periods of construction doesn't mean different purposes. I mean," she stopped. "Sorry, I'm probably missing something. I just couldn't find where this had been tested in the literature." Selvin looked at her for a moment. Then he said, "It hasn't been in the way you're describing. We've cross-referenced the systems but not modeled them as you put it, a two-part communication." He paused again. "Then, that's a reasonable observation." He said it carefully, the way you'd lower something fragile onto a table. After the session, 3 of my colleagues came to find me and told me that the student had asked an interesting question. All 3 of them said it in the exact same tone, the slightly reluctant voice of someone acknowledging that a child has said something accidentally clever. None of us in that moment understood what she'd actually seen. Chapter 10, Second Week, The Access. At the start of the second week, Station Director Cole did something that surprised most of the faculty. She granted the human cohort expanded access to the research archive, including documentation that was normally restricted to senior researchers. And she moved their daily observation post from the 15-meter boundary to a 7-meter boundary. When Professor Selvin asked her about this privately, she said she was following instinct. He was not pleased, but she was the station director and it was her decision. Myra spent the second week almost entirely at the new observation post, 7 meters from the surface of the engine, close enough that you could see the fine detail of the markings without optical enhancement. She was there every day from first light to meal break, and then again from after the meal to when the protective UV filters came on for the night. She wrote in her notebook, she photographed, she made small sketches, she occasionally recorded voice notes into her personal device. She did not talk to many people during this time. The other students were in shadowing assignments, following researchers around, sitting in on analysis sessions. Myra had technically been assigned to shadow Dr. Vell, our lead surface analyst. Dr. Vell told me later that Myra had politely asked, on the first day of shadowing, if she could spend her time at the observation post instead of following him around. He'd said he supposed that was fine, since she wasn't a credentialed researcher and couldn't contribute to the active work anyway. He'd said it without malice. He genuinely believed it. Chapter 11, What She Was Seeing. I found out later, much later, when I read her notes. What Myra was doing during those long days at the observation post. She wasn't just looking. She was building a model in her head. Not a mathematical model. She didn't have the formal mathematical framework for that, and she knew it. A different kind of model. She was watching the way light moved across the engine's surface at different times of day, and she was noticing that the shadows fell differently on different marking clusters depending on the angle. This sounds simple. It is not simple. The engine's surface is not flat. It's subtly curved, with depth variations in the markings that create microtopography across the whole surface. This was documented. We knew the surface wasn't flat, but the data existed as numbers in a topography survey. The numbers told you the depth variations existed. They didn't tell you what the depth variations meant when you watched them interact with actual light in actual time. Myra watched the light move across the surface for 6 days. On the 6th day, she started to understand what she was looking at. In her notebook on that day, she wrote, "It's a key, not like a map, not like a machine, not like a diagram. It's a key. The markings tell you what position to put energy into. The depth variations tell you the sequence and the intensity. It's like, imagine someone built a lock and then they put the shape of the key right on the outside of the lock so that anyone who looked carefully enough would know what the key needed to look like. But you'd have to look at the shadow, not the shape, because the shape is just decoration. The shadow is the information." She underlined the word shadow 3 times. Then below it, the energy source is already inside it. The warm temperature, it's been running for 5,000 years, probably longer. It's not waiting for an outside energy source. It's waiting for a signal. A specific pattern of signal applied to specific points in a specific sequence. The exterior markings aren't instructions for the operator, they're the waveform. They're showing you what the signal has to look like. She was 16 years old. She had no formal training in resonant architecture theory. She had never published a paper, attended a graduate-level course, or been credentialed in any scientific discipline. She had just figured out in 6 days of watching shadows what 5,000 years and the greatest minds in the galaxy had not. Chapter 12, the morning of day 11. The morning of day 11 of the cohort's stay, Myra came to me. Not to Professor Selvin, not to Station Director Cole, to me. I think she came to me because I was the one who'd given the initial tour. I was the one who told her she couldn't cross the boundary. I was, in some sense, the person she'd been talking to from the beginning, even without talking. She knocked on my office door at 600 station time, before most of the faculty were even awake. I opened the door, and she was standing there with her notebook and a slightly apologetic expression. She said, "I'm sorry to bother you this early. Do you have a minute?" I said yes, of course. I gestured for her to come in. She sat down across from my desk and put the notebook on the table. She opened it to a page near the end and turned it to face me. "I think I might understand something about the engine," she said. The page she showed me was covered in sketches, not mathematical proofs, not computational models, drawings. The surface of the engine from different angles, with the shadow paths sketched in at different times of day, with small arrows showing the relationships between marking depth and shadow direction. And then, at the center of the page, a diagram that looked like, I don't have a better word for it, a key. Not a physical key, a pattern. A sequence diagram showing what looked like a series of energy pulses, their relative intensities, and the points on the engine's surface where they should be applied. I looked at it for a long time. Then I looked at her. She said, "I know I'm probably wrong. I know I've only been here 11 days and there are people here who have been studying this for their entire lives. But I kept looking at the shadows and I kept thinking nobody seems to have modeled what the depth of the markings does when light hits them at different angles. Like, the topography surveys exist, but they're static data. They don't tell you what happens over time. And when you watch it over time, it looks like..." She tapped the diagram. "It looks like this." I said, "Where did you get the idea that the exterior markings are showing a waveform?" She looked slightly surprised. She said, "They're not symmetric. I kept noticing that the deeper markings are always on one side of a cluster and the shallower ones are on the other. Like the marks themselves have a slope to them. And when I thought about what kind of information you'd convey with a sloped mark instead of a flat one, depth implies direction, direction implies sequence, sequence implies..." She gestured at the diagram. I said nothing for a moment. She said, "Is this something that's already been modeled?" I couldn't find it in the literature, but maybe I missed it. I said, no, this hasn't been modeled. She said, oh, a pause. Is it worth showing to someone who'd know if it was wrong, like Professor Selvin? I was already reaching for my comm. Part 2, the key. Chapter 13, the emergency faculty meeting. I need to describe, as accurately as I can, what happened when I showed Myra's notebook to Professor Selvin. I should say first that Selvin was not a petty man. He was not the kind of scientist who dismissed ideas because of where they came from. He was not threatened by good ideas from unexpected sources. In 40 years of working with him, I had seen him give credit generously, acknowledge error readily, and treat junior researchers with genuine respect. But when I put Myra's notebook on his desk and told him where it came from, something happened to his face that I hadn't seen before. He looked at the notebook for a very long time. He didn't pick it up right away. He just looked at it like it was doing something he needed to finish watching before he responded. Then he picked it up. He went through it page by page, all 3 weeks of notes, not just the final diagram. He read every entry. He studied every sketch. It took him 40 minutes. When he was done, he put the notebook down carefully. He was quiet for a moment. Then he said, "Get Cole, get Vel, get Mariseth and Thorvin from the Interior Survey team. Get them all here in the next 20 minutes. I said, should I bring the student? He thought about that, then he said, yes. The emergency faculty meeting lasted 3 hours. I cannot reproduce the entire transcript here. It's in the archive at reference code FC4897B, but I can tell you the shape of what happened. Selvin presented Myra's observations to the assembled senior faculty. He did it without editorializing, just laid out the logic step by step. The shadow analysis, the depth-direction correlation, the waveform hypothesis, the sequencing diagram. The initial response was, predictably, skeptical. Professor Mariseth, senior researcher, Interior Survey lead, 25 years on the station, said the waveform interpretation was incompatible with the established understanding of the marking compositional structure. Myra, who had been sitting quietly in the corner with her notebook, said, I know. But the compositional structure analysis was done with the exterior and interior systems treated separately. I'm suggesting they're one system. If they're one system, the compositional structure of the exterior markings describes the output state, not the input state. Mariseth looked at her. There was a long pause. He said, he stopped. Another pause. He said, that's a coherent alternative interpretation. Thorvin, from the Interior Survey team, pulled up the interior marking data on his display and started comparing it against Myra's diagram. After about 20 minutes of silent analysis, he said, if the exterior markings describe a waveform pattern, the interior sequences could be modeling the response to that waveform. The resonance cavities in the interior lattice, we never understood why they were shaped the way they were. But if you're right about the input signal pattern. He didn't finish the sentence, he just started typing. Myra said very quietly, the interior is showing you what happens after you give the right signal, like it's already preloaded with the response. It just needs the input to trigger it. Dr. Vel, who had been my assigned shadow mentor for Myra, and who had spent 11 days assuming she wasn't contributing anything, said, in a voice I'd never heard him use before, how did you see this? She said, I watched the shadows. Every day I just watched how the shadows moved. He said, we have 40 years of photometric data from the plateau. She said, I know. But I read the photometric reports and they measure light intensity, not shadow shape. It's not the same thing. He thought about that. He said, no, it's not. Chapter 14, the simulation. After the faculty meeting, we ran simulations. We had to build new models. Myra's framework didn't fit any of our existing computational architectures. So Thorvin and 2 other researchers spent 36 hours coding from scratch, building a new simulation environment based on her waveform hypothesis. We ran the first simulation at approximately 200 hours on the morning of day 13. The result was immediate and unmistakable. The simulated engine, built from 40 years of topographic and compositional data, responded. Not in a vague, ambiguous, we might be seeing something way. In a clear, definitive, every sensor in the model lighting up way. Thorvin stared at the results for about 30 seconds. Then he said very quietly, "It works." 3 other people in the room were also staring at the results. Nobody said anything for a while. Then Vel said, "We need to test it on the actual engine." Selvin said, "Yes." I said, "We need to get the student." Chapter 15, the morning of day 14. The morning of day 14. This is the part I remember most clearly, the part that I'll carry with me for the rest of my life, regardless of how long that turns out to be. Vithrak Prime at dawn is not beautiful. The sky goes from very dark gray to slightly lighter gray, and there's a thin cold wind off the plateau that smells exactly like rust, and the ground under your boots makes a crunching sound that's not quite rock and not quite ice. The engine sits in the middle of all of it and seems to absorb the light rather than welcome it. We gathered on the plateau at 5:30. The full senior faculty, Selvin, Mariseth, Thorvin, Vel, 12 others. Station Director Cole. 3 representatives from the consortium observation team who had been on the station for a routine inspection visit and were now very urgently awake at 5:30 because someone had told them something significant might be happening. And Mariseth. She was wearing her bio suit. She had her notebook. She looked like what she was, a 16-year-old girl standing on an alien planet in the cold before dawn, surrounded by researchers who were simultaneously treating her with profound respect and trying very hard not to show how nervous they were. She looked nervous too. She was gripping the notebook with both hands. I walked over to her and stood next to her. She said, "What if the simulation was right but my waveform diagram is wrong? Like, what if the theory is correct but I calculated the sequence incorrectly?" I said, "Then we'll learn something useful and try again." She said, "Yeah," a pause, "okay." The test equipment had been set up overnight, a precision energy emitter array, calibrated to Myra's waveform specifications. It was positioned 7 meters from the engine's surface, pointed at the cluster of markings that her analysis identified as the primary interface point. The plan was simple. Selvin would authorize the emission sequence. The array would emit the signal we would observe. I looked at the engine in the thin gray light and thought about the 5,000 years of researchers who had stood on this plateau and tried and failed. The expeditions and the academic conferences and the competing theories and the 47 replaced beacons and the 20,000 people who had lived in the rust-smelling air and given their careers to this thing. I thought about Dr. Patricia Ackhaffer at the conference, raising her hand, being politely dismissed. I thought about what it meant that a 16-year-old girl with a paper notebook had seen what none of us had. Selvin looked at Myra. He said, "You should be the one to authorize it." She looked surprised. She said, "It's your research station. I've only been here 2 weeks." He said, "It's your theory." She hesitated, then she said, "Okay." She said, "Do it." Chapter 16, 11 minutes and 40 seconds. The emission array activated at 5:47 station time. For the first 40 seconds, nothing visible happened. I was counting, I couldn't help it. 41, 42, 43. Then at approximately the 50-second mark, the engine changed. Not dramatically, not immediately. It started with a sound, a low, subsonic vibration that you felt in your chest before you heard it with your ears, like the planet was clearing its throat. The ground under our boots transmitted it, and several people shifted their weight involuntarily, bracing against something they couldn't quite locate. Then the markings lit up. Not all at once, in sequence. Starting at the primary interface cluster that Myra had identified, the markings on the engine's surface began to emit light, deep, rich amber light, the color of very old honey, beginning at the first point in her sequence and then moving to the next, and the next, in exactly the order she had drawn in her diagram. The sequence traveled around the engine's circumference in a spiral pattern, moving from the primary cluster around the eastern face, across the northern face, to the western, to the southern, and then beginning to climb, following the spiral upward, the amber light tracing the markings in motion, like watching a sentence being read. Someone behind me said something in Vilthari that I won't translate. Myra was completely still. The sequence continued for 8 minutes. The amber light moving through the markings, illuminating the engine in a pattern that none of us had ever seen, that nobody alive had ever seen, that nobody in any living memory had seen. At the 8-minute mark, the light changed color. From amber to something that didn't have a name in my language, a blue that was somehow simultaneously warm, a color that seemed to come from inside the crystalline structure rather than from the markings themselves. It spread across the entire engine surface simultaneously, and then the engine did something that the topographic surveys had told us was physically impossible. The top section moved. Not much, not dramatically. A rotation of maybe 15 degrees, the upper portion of the engine turning slowly and smoothly, completely silently despite 5,000 years of immobility, revealing a gap at the join between the upper and lower sections. A gap that had always appeared to be a decorative seam, and was in fact, it turned out, an aperture. From the aperture came light. The same blue warmth, purer now, projected upward into the gray Vthrock sky as a column of light that went up and up until it diffused into the clouds. At the 10-minute mark, the light column stabilized into a coherent beam. And then, this is the part that the observation team's instruments recorded, but that none of us understood until the data was analyzed 3 days later. The beam began transmitting a signal. A complex signal, layered, structured, containing what the analysis eventually determined was an enormous quantity of information. Encoded information, a message. Someone had built this engine 5,000 years ago and left a message inside it, waiting for whoever figured out how to turn the thing on. At 11 minutes and 40 seconds, I stopped counting and started crying. I'm not embarrassed to say that. I was 53 years old and I had spent 22 years of my career studying this object. I was standing on a gray plateau in the early morning with rust-smelling air coming off the wind, watching a 5,000-year-old machine come to life because a 16-year-old girl with a paper notebook had watched shadows. I put my face in my hands and I cried. Chapter 17, After. What happened immediately after is harder to describe clearly because everything happened at once, and my memory of it is less linear than the rest. The consortium observation team was immediately on their communications equipment, sending urgent dispatches to Consortium Central. Station Director Cole was giving rapid instructions to the research team about instrument priorities. Selvin was standing very still, looking at the light column, with an expression I'd never seen on his face. Myra was sitting on the ground. Not collapsed, she'd sat down deliberately, cross-legged on the plateau surface, notebook open in her lap. She was writing in it. I went over to her, I crouched down next to her. She looked up at me. Her eyes were red at the edges. She'd been crying too, I realized, at some point in the last 11 minutes. She said, "What's it saying?" I said, "We don't know yet. It'll take time to decode the signal." She said, "Okay." She looked back down at her notebook. She was writing. "I want to write down what I saw before I forget anything." I said, "You won't forget this." She said, "I forget things all the time. My mum says I'd forget my own head." I sat down on the plateau next to her. Cold, hard surface, rust-smell air, amber-turned blue light coloring the gray sky. I said, "How did you know to watch the shadows?" She said, "My grandmother used to take me to church when I was little. The building was very old, like hundreds of years old. And the windows were these old stained glass windows, and in the afternoon, the sun would come through them and make these patterns on the floor. Different times of day, different patterns. And my grandmother always said, she'd say, 'Myra, if you want to understand a beautiful thing, watch where it puts its shadow.'" She meant it spiritually, I think, but I kept thinking about it when I was looking at the engine. She paused. "The engine is thousands of years old. I kept thinking whoever built it had to be like a person, like a real person. And real people, when you make something important, you want people to be able to find the meaning. You put it somewhere they'll look." She looked back at the engine. She said, "They put it in the shadow." Part 3, The World After. Chapter 18, What the Engine Said. The signal took 19 days to fully decode. I will not summarize the entire content here because the full decoded transmission is its own archived document. Reference code GCA SIRATH signal 001, approximately 40,000 pages of data. But I can tell you the shape of what we found. The builders of the Surath engine were a species called, in their own language, something that translates approximately as the ones who came before the silence. They were an ancient species, extinct before the Galactic Consortium existed, who had traveled the galaxy during what they called the First Age. They were not the oldest species we'd ever found evidence of, but they were among the most advanced. The engine was not a power source, it was a library. Specifically, it was a library of everything the ones who came before the Silence had learned about the galaxy before their extinction. Scientific knowledge, historical records, philosophical texts, and what appeared to be a detailed map of locations throughout the galaxy where they had left similar structures. Not one engine, 14. The signal from the Vithrock engine contained the activation codes for all 14. The total knowledge contained in the full network, once unlocked, represented what the analysis team eventually estimated as a 10,000-year acceleration of galactic scientific progress. Medicine, energy systems, materials science, propulsion, communication. 14 engines worth of knowledge from a species that had been building civilization when the ancestors of the Velthari were still living in trees. All of it inaccessible for 5,000 years. All of it waiting for someone who thought to watch where the shadows fell. Chapter 19, The Reckoning. I want to be honest about what happened inside the scientific community in the weeks and months after the engine activated. There was celebration, obviously, enormous, genuine, galaxy-spanning celebration. The discovery made every major communications channel in the consortium simultaneously. The signal was replicated and shared. The 14 engine locations were identified and expeditions dispatched. The scale of what had been found was impossible to overstate. But underneath the celebration, in the meetings and the private channels and the late-night conversations between researchers who'd been on Vithrock Prime for years, there was something else. A reckoning. Professor Mariseth said it directly in the senior faculty review session 3 weeks after the activation. He was addressing the full faculty, and he was 72 years old and had been studying the engine for over 30 years, and he said, "We need to have an honest conversation about why we missed what that student saw, not to assign blame, to understand." The conversation lasted 6 hours. What emerged from it was hard, harder than most of us wanted to admit. We had been looking for complexity. For years, for decades, the entire research approach had been oriented toward complex solutions, advanced mathematical frameworks, multi-dimensional computational models, elaborate theoretical structures. Because that was what advanced science looked like. That was what serious science looked like. Myra had solved it by sitting quietly and watching shadows. The reason nobody else had thought to do that was not stupidity. We were not stupid. Every researcher who had spent time on the plateau was intelligent, educated, dedicated. We had done real and important work documenting the engine, understanding its composition, cataloging its markings. But we had all been trained in the same tradition. We all came to the problem with the same framework. We all assumed, without quite saying it out loud, that the answer would look like a complex answer. Because that was what answers looked like in our experience. We had built a cage out of our own expertise and sat inside it for 5,000 years. What Myra had was not better intelligence. She had, and I've thought about this more than I've thought about almost anything in my life, she had no expectation. She had no framework for what the answer should look like. She had no investment in any particular theory. She had no colleagues to impress or disappoint. She had no career built on any interpretation that needed protecting. She had a notebook, a grandmother's advice, and an open eye. Chapter 20, The Human Question. The reckoning extended beyond Vithrock Prime. The human cognitive assessment, the one that had classified humans as Class 4 intelligence, below the threshold for advanced abstract mathematics, became the subject of an urgent review by the Consortium Science Council. The review lasted 8 months. The conclusion was significant. The cognitive assessment had been developed over 2,000 years to measure intelligence in the ways that the species who developed it understood intelligence. It measured mathematical modeling ability, multidimensional geometric reasoning, recursive logic processing, all things that the consortium's dominant species were very good at, all things that formed the basis of consortium scientific practice. It did not measure contextual lateral synthesis in any rigorous way. It noted the human excellence in this area, but treated it as a supplementary capability rather than a core intelligence metric, something nice to have but not scientifically central. The review determined that this was wrong. Not just slightly wrong, categorically wrong. Contextual lateral synthesis, the ability to pull together information across unrelated domains and find the connection nobody else saw, was not a supplementary intelligence. It was a different kind of intelligence, equally valid, differently powerful, in certain kinds of problems more powerful. Humans were not class 4 intelligence. They were a different kind of intelligence that the assessment wasn't equipped to measure properly. The review recommended a complete revision of the cognitive assessment framework to include human-style reasoning as a first-class capability. Alongside the mathematical modeling capabilities the existing system prioritized. It also recommended the immediate full inclusion of humans in consortium advanced research programs. The vote was not unanimous, but it passed. Chapter 21, Myra. After the activation, Myra's 4-week cohort placement became indefinite. She didn't stay on Vithrock Prime. There was a period of intense scientific consultations and documentation sessions, and then she went back to Earth to finish her schooling. She was, after all, 16. She had exams to sit. But she was registered as a contributing researcher on the Surath engine activation. The official discovery record lists her name alongside Selvin's, which was a decision Selvin advocated for personally. She was offered a full research fellowship at the Velthari Institute, beginning whenever she completed her secondary education. She sent me a message from Earth about 2 months after she left. I have it saved, it said. I keep thinking about how strange it is that the answer was there the whole time, like it wasn't hidden deeply or encoded in a way that was meant to be hard. The builders put the information on the outside. They wanted whoever found it to be able to understand. They'd thought about it from the finder's perspective. I think they must have been really kind, actually. To think about the person who would come after them, who wouldn't know anything, and to make sure that person could still find the way in. Then, I hope we're kind like that to whoever comes after us. I reread that message more than is probably appropriate for a senior researcher of my standing. Chapter 22, The 14 Engines. The expeditions to the 14 engine sites took the better part of a decade. Each one was activated using the codes from the Vithrock signal. Each one, once activated, transmitted its own unique signal, its own section of the vast library that the ones who came before the Silence had built and left and waited 5,000 years for someone to find. Some of the engines were in deep space, orbiting dead stars. Some were on the surfaces of planets, like the Vithrock engine. 2 were underwater on ocean worlds. 1 was inside the atmosphere of a gas giant, which was a complicated expedition. Each activation was its own event, its own moment. I attended 4 of them. None of them felt exactly like the first one. Nothing ever does. But each one had something of the same quality, that feeling of watching a door that had always been there, closed, just open. The feeling of something ancient exhaling. The knowledge from the full network took decades to process and translate. Some of it is still being analyzed as I write this. But the early impacts were significant and rapid, breakthroughs in several areas of materials science and propulsion theory that would have taken, by conservative estimates, several centuries to arrive at on our own. 14 engines, 1 16-year-old girl with a paper notebook. The math of that is not complicated. Chapter 23, What I Carry Forward. I am writing this archive document in what the station calendar marks as year 4810 of the consortium calendar, approximately 70 years after the activation, accounting for the time I've spent at various research postings. I am old. This is not unusual. Velthari have long lifespans, but it registers differently than it did when I was young. Each year feels more like a gift than an expectation. I retired from active engine research about 15 years ago. I still consult occasionally. Mostly I write archive documents like this one, review articles, the occasional piece for the popular science publications that cover the ongoing work. Myra is an established research fellow at the Velthari Institute now. She leads a team working on the analysis of the 12th engine's signal, which contained an unusual quantity of what appears to be philosophical content. She publishes good work, careful, original, methodologically strange in ways that her colleagues have learned to take seriously before they understand them. She still uses a paper notebook, as far as I know. I have thought more times than I can count about what the Surath engine's story means, what it teaches. I'm a scientist, not a philosopher, and grand lessons make me uncomfortable. The universe doesn't usually owe us lessons, in my experience. Things just happen, and we make what sense of them we can. But if I had to articulate something that I've carried with me from that gray plateau on day 14, from the moment the amber light began to move through the markings in the early morning cold, it's this. Intelligence is not one thing. It was never one thing. We built a galaxy-spanning civilization and a 2,000-year cognitive assessment framework, and we still, somehow, kept treating intelligence as if it had one shape. As if the highest form of thinking was the form we were best at. The ones who came before the silence built their library, and they sealed it with a lock that required not advanced mathematics to open, not multidimensional geometric reasoning, not recursive logic processing. They sealed it with observation, with patience, with the willingness to sit on a cold plateau and watch where the shadows fell. They had thought about who would come after them, and they had trusted that whoever that person was, whatever form their mind took, they would have this much: the ability to be still and look and see. They were right. They'd been waiting 5,000 years, and they were right.